Let's start with the application of differentiation. Let me tell you the meaning of differentiation. Differentiation means calculating the immediate rate of change of quantities and the technique for determining a function derivatives. The rate change of a function is fx. Let me tell you in more detail. Definition of applied maximum and minimum problem are the process of finding maximum or minimum value is called optimization. How do we solve those equations? There are 3 steps, which is first, find the derivative. Second, let the derivative equal to 0 and find the value of the variable. Third, second derivative test. If the derivative is bigger than 0, it's known as minimum value. But if the derivative is lower than 0, it's known as maximum value.
Problem statement. A closed cylindrical container of radius r cm and height h cm is to be made to hold 600 cm cube of liquid. We have 3 questions here, A, B and C. A. Show that the surface area of the container is 2 pi r squared plus 1200 over r. Question B. Find the values of r and h that minimize the total surface area of the container. Give your answer correct to 2 decimal points. C. Find the minimum surface area of the container. Show that the surface area of the container is 2 pi r squared plus 1200 over r. Given volume of the cylinder, equation given is 600, and the formula of volume of cylinder is pi r squared h equal to 600. Since we want to know the h value, we bring pi r squared to the right. It became 600 over pi r squared. Therefore, the formula of area of the cylinder is 2 pi r squared plus 2 pi r h. So we bring this value of h down here. So it will be 2 pi r squared plus 2 pi r in brackets 600 over pi r squared. Answer will be 2 pi r squared plus 1200 over r. Find the values of r and h that minimize the total surface area of the container. We have to find the derivative first. A stands for area equals to 2 pi r squared plus 1200 over r. You can also write them down like this. Since we are going to differentiate them, we write dA over dr equals to 4 pi r minus 1200 by log of negative 2. Lastly, we write then 4 pi r minus 1200 over r squared. Second step is let the derivative equals to 0. Let dA over dr equals to 0. So 4 pi r minus 1200 over r squared equals to 0. We bring it to the right side. The 4 pi r equals to 1200 over r squared. This r will multiply with this r. Become 4 pi r cube equals to 1200. The next step, we leave r cube in the left side. R cube equals to 1200 over 4 pi. So 1200 over 4 pi. The answer is 4.57 cm. The third step, second derivative test. d squared a over dr squared equals to 4 pi plus 2400 r power of negative 3. We can write them down like this. When r equals to 4.57, write the equation down here because we want to let r equals to 4.57. d squared a over dr squared equals to 4 pi plus 2400 over 4.57 cube, 37.71. It is higher value than 0. r equals to 4.57 cm is a minimum value. When r equals to 4.57, bring back the equation of h equals to 600 over pi r squared. Bring the value in 600 over pi in brackets 4.57 squared. Its answer will be 9.14 cm. Question C, minimum surface area of the container. We already know that H is 9.14 cm and the radius is 4.57 cm. We write down the area of cylinder that we wrote in the first question is equal to 2 pi r squared plus 1200 over r. For the minimum surface area equals to 2 pi brackets 4.57 power of 2 plus 1200 over 4.57. The last answer we get 393.81 cm squared.
Next, I want to talk about second question. Second question show a manufacturer wants to design an open box that has a square base and a surface area of 144 cm square. We have two questions which is A and B. A. Find the dimensions of the box such that the volume is maximum, and B. Determine the maximum volume. To answer the question A, we can see the diagram. V equals to x squared times y, given the surface area is 144. So x squared plus 4xy equals to 144. Then we bring the x squared to the other side, so it will be 4xy equals to 144 minus x squared. So after that we can get y value, which is y equals to 144 minus x squared divided by 4x. V equals to x squared times y. After that we add the y value, so it will be x squared in bracket 144 minus x squared divided by 4x, and it will be 144x minus x cubed divided by 4. And after we simplify the equation, so we can get 36x minus 1 over 4x cubed. In this question, we need 3 steps, which is step 1, step 2 and step 3. In step 1, we need to find the derivative. So V equals to 36x minus 1 over 4x cubed. So after that, dV over dx equals to 36 minus 3 over 4x squared. In step 2, let the derivative equal to the 0. We need to let the dV over dx equal to 0. 36 minus 3 over 4x squared equals to 0. And 36 equals to 3 over 4 x squared. After that, 48 equals to x squared. And at the end, we can get x equal to 48 cm. In step 3, we need to do second derivative test. So d square v divided by dx square equals to 0 minus 3 over 2x. So the answer will be negative 3 over 2x. So when x equals to 48, d square v divided by dx square equals to negative 3 over 2 in bracket 48. So the answer will be negative 10.39 less than 0. So x equals to 48 cm is a maximum value. When x is 48 cm, so y it will be 144 minus 48 square divided by 4 times 48. So the answer will be 3.46 cm. Next, to answer the question B, V maximum equals to 48 square times 3.46. So the answer will be 166.08 cm cube. Or we can do V maximum equals to 36 in bracket 48 minus 1 over 4 in bracket 48 cube. So the answer it will be 166.28 cm cube.
The conclusion of differentiation, particularly in determining maximum and minimum values, is that it enables us to discover essential spots on a function and analyze their nature to identify local maxima and minima. To summarize, differentiation assists us in determining the maximum and lowest points of a function by taking its derivative, solving critical issues, and analyzing the second derivative. We can find the absolute maximum and minimum values by comparing function value at these places.